So get out your take-home quiz, please. I'll pause for a second or two while you're waiting, while I'm waiting for you to get your quizzes out. Okay? And of course we'll go with my favorite student, good old Anne. And here we go. It says, give the measure of each angle in degrees. Okay. If I look at number 1A, looks like I went 360 and another 360 and 51 degrees more. It's going to be 360 and another 360 and 51 degrees more. It's going to be 360 and another 360 and 51 degrees more, 771 degrees. B, 360 and, okay. Looks like I went 360, that's that much, and then I went 180 further, and then looks like I went 60 more degrees, that little wedge right there. So I think it's going to be 360 and 180 and 60, which is going to be, I should be able to do this in my head, but it's late. 360 plus 180 plus 60, 60, Mr. Dueck. 600 degrees. Now we're going backwards. Negative 360. And then that much further. Well, this whole thing is 90, so 90 take away 33. This must be 57 degrees. So the whole angle has got to be negative 360 and then 57 degrees more negative, so minus 57. Negative 360 minus 57. You know what? It's negative 417 degrees. 1 mark. D. Okay, looking at this picture, again, it looks like we're going this way, which does mean negative, and it looks like we have gone, I got to zoom in a little bit here. Looks like we have gone once, that's 360, negative. Twice, that's another negative 360. That far, a negative 180. And then 58 degrees more in the negative direction. It's going to be negative 360 times 2, and then plus negative 180 plus negative 58. Of course, instead of going plus negative 180, I could have just gone take away 180, and instead of going plus negative 58, I could have just gone take away 58. Negative 958 degrees. All right, draw the following rotation angles in standard position. Positive, okay. That's 90. If I kept going all the way to here, that would be 180. So it's going to be right to about there. Now, if you have that, I'll give you full marks. For what it's worth, it seems to me that that right there must be 30 degrees. That right there must be 60 degrees. You didn't have to label that, but you're probably closer to the 90 than you are to the 180. That's all I'm saying. B, 200, really you have to get the right quadrant. You're in quadrant 2. B, 243 degrees, somewhere in there. It's 180. It's past 180, but it's not 270. It's in here somewhere. If you really want it to be fussy, if that's 180 and this whole thing is 243 degrees, it seems to me that this must be 63 degrees right here. And the little chunk right here must be 27 degrees, but whatever. I didn't say to label that. 337 degrees is going to be 90, 180, 270. 337 is somewhere in there. Just a little bit less. Now, again, if you want it to be fussy, I think it's 23 degrees below 360 degrees. But again, I didn't make you label that part. I just want to know that you're in quadrant 4. 70, right about there. Negative 203. There's negative 180. This would be negative 270. That's too far. So negative 203, somewhere in there. 537. Well, there's 360. 450. 540, oh, that's too far. You know what? You're just shy of 540 degrees. In fact, I can tell you, I think you're exactly 3 degrees shy of 540 degrees. Again, I didn't make you label the 3 degrees. What I'm looking for is, did you go and end up here? 1 mark for each of those. So number 1 out of 4, number 2 out of 6. Convert from radians to degrees. From degrees to radians. Express your answer as an exact value in terms of pi. So it's going to be 30 degrees times pi radians over 180 degrees. Really, all I'm going to do is I'm going to reduce that fraction. All I'm going to do is I'm going to reduce 30 over 180 in lowest terms. This is pi by 6. Yes, it's 1 pi by 6 because the fraction I got was 1/6. You know what? I don't care about the 1. Pi by 6. 45 degrees. Again, that's going to be 45 degrees times pi radians over 180 degrees. It's going to be in terms of pi, and all I'm going to do is I'm going to reduce 45 over 180. 45 over 180. Pi by 4, 1/4, but I'm just going to write pi by 4. I'm not going to bother writing the 1. 60 degrees. It's going to be 60 degrees times pi radians over 180 degrees. I'm going to reduce the, you know what, 60 over 180, I think it's 1/3. I think this is, the pi sticks around, it's 1/3 of pi, or pi by 3. 135 degrees. It's going to be 135 degrees times pi radians over 180 degrees. I'm going to reduce that part. The pi is going to stay in the answer. 135, fraction button 180, 3 pi by 4. $240 degrees. Stop. Look up. Look up. Look up. Yes, you too. Look up. I could go 240 degrees times pi over 180. Or, if I'm clever, I might notice that 240 is 4 times bigger than 60. 240 is 4 times bigger than 60. 240 is 4 times bigger than 60. It's going to be 4 pi by 3s. 1 mark for each of those out of 5. Turn the page. From radians to degrees. Again, I'm going to multiply, but this time I'm going to multiply by 180 over pi. The pi's will cancel, and I'll get 180 over 2. You know what? Pi by 2 radians is 90 degrees. I'm going to multiply by 180 over pi. This is our conversion factor. Pi cancels. I get 180 over 4, which I'm pretty sure is 45 degrees. 180 over 4, or divided by 4, it doesn't matter. 45. C, negative, times 180 over pi. The pi cancels. It's going to be 2 times 180 divided by 3. Well, 180 divided by 3 is 60. It's going to be 2 times 60. I'll bet you it's going to be a negative 120 degrees. Yep. Pi by 6. Now, I did that a couple of ways. I happen to remember it from back here. Pi by 6 is 30 degrees. Actually, what I know is pi is 180 degrees, so 1/6 of 180 is 30 degrees. Or you could go times 180 divided by pi. The pi's will cancel, and you will get 180 divided by 6. It's trickier when you're leaving answers as decimals, but it's easier on your calculator. So now it wants me to, in other words, don't leave my answer as an exact value in terms of pi. Okay, I'm going to go times pi divided by 180, and I'm literally going to go 50 times pi divided by 180. 50 radians is approximately 0.87, I guess, to 1 decimal place, 0.9 radians. And radians you can write rad if you really want to, or no unit is appropriate because radians is actually technically not a unit at all. 205 degrees, I'm going to multiply it by pi over 180 degrees. I'm going to get 205 times pi divided by 180. 38.5 radians. No, that's wrong. I totally typed that wrong. Wow. 205 times pi divided by 180. That looks much better. 3.6 radians. By the way, I knew that was wrong because pi radians is 180 degrees, and I know that pi is 3.14. 205 is a little bigger than 180. It'll be a little bigger than 3.14. Yeah, 3.6. 57.3 degrees should be a little bigger than 0.9 radians because 50 degrees is 0.9 radians. I'm going to multiply by what? Yeah, you said it. Pi over 180 degrees. It's going to be 57.3 times pi divided by 180. You know what? That's pretty close to 1 radian. Times by pi. Little note to myself to do some more homework there. All over 180. Also a note to myself to plan out the year end. All over 180 degrees. Oh, 250 times pi divided by 180, 4.4 radians times pi over 180 degrees, 120 times, now if you want to, you could go 120 fraction button pi times pi, pi fraction button 180, and you get 0.6. It's 2/3, or as a decimal, 0.7. If you wrote 0.6, half mark. Round off properly, please. All right, how about from radians to degrees? Times 180 divided by pi. 0.5 times 180 divided by pi. It does say give your answers to the nearest tenth. 28.6 degrees. 28.6 degrees. 3.1, rad. It's going to be 3.1 times 180 divided by pi. 177.6 degrees. 0.4 radians is going to be 0.4 times 180 divided by pi. 22.9 degrees. 1.8 pi radians is going to be 1.8 pi times 180 divided by pi. 324 degrees. I'm going to be fussy. If you forgot the degrees symbol anywhere, you'll lose a half mark. Not on every single time you did it, but at least once. Because otherwise you're telling me your answer, if you didn't put the degrees symbol there, is in radians. That's radians, no units. You don't have to write rad or radians. Nothing means radians. Sketch the following angles in standard position. Let's make this nice and big. In fact, I think I can make it bigger than that. 7 pi by 6. Pi by what? Pi by 6. Pi by what? Pi by 6. So I'm going to call this 6 pi by 6, which is pi, which means this is 3 pi by 6, halfway to 6. And now it means every one of these is worth 3, so that must be 9 pi by 6. So you know what? 3 pi by 6, 6 pi by 6, 9 would be too far. 3 pi by 6, 6 pi by 7 pi by 6 is in that quadrant right there. B, 3 pi by 4. Pi by what? Pi by 4. Pi by what? Pi by 4. I'll call that 4 pi by 4, which is still 1 pi. That makes this 2 pi by 4. Oh, you know what? 3 pi by 4, I can even be more specific. It's exactly halfway. It's right there. 11 pi by 6. Pi by what? Pi by 6. Pi by, okay. I'm going to call this 6 pi by 6. That's 3 pi by 6. I guess that's 9 pi by 6. You know what? This is 12 pi by 6, which is still 2 pi. Oh, 11 pi by 6? Yep. Just shy of 12 pi by 6, somewhere in that quadrant. D, negative, going to go this way. This is going to be negative 6 pi by 6. This is going to be negative 3 pi by 6. You know what? I want negative 1 pi by 6, which I get, you know what? It's going to be only about that far. I fluked into drawing it without meaning to. Negative 11 pi by 6. Pi by what? Pi by 6. Negative, though. So I'm going to go this way. Negative 6 pi by 6. Here's negative 3 pi by 6, because now we're going this way. Here is negative 9 pi by 6. Here's negative 12 pi by 6. You know what? Negative 11, just shy of negative 12. You're in quadrant 1. Negative 5 pi by 3. Negative means this way. Pi by what? Pi by 3. Pi by what? Pi. So here's negative 3 pi by 3. And if I kept going all the way, here's negative 6 pi by 3. So it's negative 1 pi by 3, negative 2 pi by 3s, negative 3 pi by 3s, negative 4 pi by 3s. I think right about here. I think it's 1, 2, 3, 4, 5. Right about there. That's a tricky one. 5 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Because each half circle is pi. 3 pi by 2. So here is 2 pi by 2. Just let me pause the video for a second. Sorry, we're back. Had a little interruption there. So pi by, there's 2 pi by 2. I guess that makes that 1 pi by 2. 1 pi by 2, 2 pi by 2. You know what? Right there is 3 pi by 2s. So this question is going to be worth 8. So can you give yourself a score, grand total, out of 36? And if you would be so kind as to hand that in, please. So if you could hand those in, stick them in block D, and we can pause the video for a second until everyone's handed stuff in. I'll sit here murmuring to myself. Murmur, 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 murmur. All right, now we're back. So, if you could get out the notes from last day, they looked like this. We had a whole bunch of practice that we were working through. We had scribbled that out, but it said graphing. We were talking about graphing, period change, and amplitude. We're going to do a couple of more, and then your homework is going to be this handout, and I have another one for you to work on. And the other one is actually a take-home quiz. Oh, yes. So what we said was it was far easier for us for the period to divide it into 4 chunks. So let's try one a little further on. We did number 8. I would love to try, oh heck, number 9, I think. Yeah, let's try number 9. So can you find this one, please? Now, if you were away, please ask for an extra copy. I think I left some, I hope. I'm just checking who was away. Oh yeah, a couple of you were away. All right. Number 9. Y equals cosine pi by 2x. Don't panic. First thing, what are we graphing? Cosine. Where is cosine going to start? Cosine is going to start, yes, up high. We said what you wanted to remember was that cosine looks like that. That's a terrible drawing, but it looks kind of like that. What's the amplitude? Remember, amplitude is that number there. What number is sitting there? It's invisible. Amplitude 1. What's the period? Well, the period is always 2 pi over b, where b is the number in front of the x. So this is going to be 2 pi over pi by 2, which is going to be 2 pi times dividing by a fraction is the same as multiplying by the reciprocal, 2 over pi. You know what? This has a period of 4. This has a period of 4. I'm going to zoom way in here. So this graph has an amplitude of 1, which means it's going to go between that and that. I can tell you it's going to bounce in here. Not going to look like that, but all right. It's cosine, so it's going to start up high. How long is the period? 4, which means if I go 1, 2, 3, 4, that's when I'm back to where I started from. Now remember, the cosine graph looks like that, which means halfway at 2, I'm down there. At 1, I'm in the middle because it's going to go top, middle, bottom, middle, top, middle, bottom. You can do the sound effects. Top, middle, bottom, middle, top, middle, bottom, middle. It's going to look like that. And I'll add a 6, an 8, a 10, and a 12. So although this looked like really scary, it actually gave me a really nice period. 4, which divides into 4 chunks really easily. Each chunk will be 1. Number 10. Let's try number 10. And then I think I'm going to let you try the rest kind of on your own, and then we'll look a little bit at these ones as well. But number 10, amplitude 1, period 2 pi over 4 pi by 5, which is 2 pi times 5 over 4 pi. The pi's cancel, kind of cool. And I get 10 over 4, or 2.5. This is a yucky period, but I'll deal with it. How long is one wave? 2.5. All right. So, let's see if we can handle this. That 2.5 is really, really yucky. But a nice number that has something to do with 2.5 is 5. What I'm going to do is this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. You okay with that? Yeah, I'm not wild about this graph. I'm kind of regretting giving it, but that's okay. I thought this was going to work out nicer. You know what? We're going to wimp out here. I apologize. You started writing. Do me a favor. Go back to the equation. Make that a 5. Make that a 4. Make it 5 pi over 4 instead of 4 pi over 5. Mr. Dueck! Make this a 5. Make this a 4. Which makes this a 4. And this a 5. No, that's even worse. God, dude. You know what? I'm going to make an executive decision right now. This is what happens when I make these up late at night. I'm going to say nuke number 10. Yay! Shut up. I mean, good. Nice. Good. Nice. Let's do number 11. Well, we just did a cos. Maybe let's do number 12. Number 12. Amplitude. Don't say negative. Amplitude is defined as positive. What's the amplitude? 2. What's the negative telling me? First of all, what are we graphing? Sine or cosine? Sine, which starts in the middle. What's the negative telling me? Instead of heading up, which way will I head? It's going to start here and head down. Not like that, but something like that. Okay, don't forget. Amplitude is 2, so I can tell you 2, negative 2. I can tell you it's going to be bouncing in there. What else? The period, which is 2 pi over the number in front of the x. 2 pi divided by a half. How do I divide by a fraction? This is the same as 2 pi times 2 over 1, which is 2 times 2, 4. The pi gets tacked on, and it's over 1. You know what? That's not going to make a difference at all. The period of this is 4 pi. So what I'm going to do is I'm going to let each square, well, I want to get 4 squares to be 4 pi. So if I make this, whoop, sorry folks. If I make this 4 pi, that's 2 pi. That's 6 pi. That's 8 pi. And 10 pi. And what are we graphing? Negative sign. Negative sign still starts in the middle, but heads down. But after 4 pi, I'm going to be back to where I started from. So I'm going to divide this into 1, 2, 3, 4 chunks. And it's going to be middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom. And then remember I said you could check your answers. If you go to your graphing calculator, you have to make sure you're in radians, which I am, good. And if you go to your y equals graph menu, delete any graphs you have there. It looks like what I've graphed goes, view window, from 0 to, looks like I went to 10, you know what? I went 10 pi, heck, I'll go to 12 pi. 0 to 12 pi. What's each square worth? A single pi. There's my scale. How low did I go? -2, so I'll go -3. How high did I go? 2, I'll go +3. Vertical scale, 1. And my equation was, gotta get it on my screen, -2 sine bracket 1/2 x. And before I hit draw, I'm even going to graph the guide railings. The top guide railing is y equals 2. The bottom guide railing is y equals -2. And now if I hit draw, it should look very similar to what I drew. And I'll even double check. I notice on my graph right here on the first hash mark, I'm touching down below. Right here on the first hash mark, I'm touching down below. I'm pretty sure I'm right. This matches my graph. So your homework, see if you can try these. Now this is writing an equation. Just see if you can figure it out. These are tricky, and I haven't attached the answers. I will go over these next class. And then if you finish that in class, I'm going to ask the teacher to hand out, here's a take-home quiz, asking for the amplitude, tell me the period, amplitude, period, and even going into some range questions. Think about it. If you know the amplitude, you know the range. You can use your graphing calculator if you need to, but not, always. What's the amplitude? And then I'm going to be giving you some graphs, and I'm going to be saying, tell me the equation. See if you can figure out what it has to be. This is tricky, but this is also due next class. Okay? And next class is Friday. Thanks.